So now that we had some time to read this on our own, can somebody explain to me what they want to do here with the cereal and the dry food? Yes, sir.
They want to make a cereal with like that 60 kilogram cereal that costs $3.75.
Right. They want to they want to mix these two things together, the cereal and the dry food, so that when they sell it, they want to make sure it's 375 375 per kilogram, right? Why don't they just put 30 kilograms of cereal and 30 kilograms of dry fruit and sell it that way? Why do we even have this problem? Why don't they just put half and half? Yeah, Shra?
It's not a good mixture. Cereal.
No, actually, that's not the actual point. It's not just because it may not taste good or anything.
Oh.
Yeah, Derek, what do you think?
It has to be in the separation.
It has to be?
In the separation.
What do you mean by that?
Like, it has to be like a certain amount of the dried fruits and a certain amount of
Right. We don't want half-half, right? Why not? Emily? He's right. Yeah, we want a certain amount, right? Why we don't want half and half? Why not? Yeah.
Why should they want it?
The price will be higher. Is that right? Because, right? Oh, yeah, because as you can see, how much is the dry fruit per kilogram? $9, whereas the cereal is only $2. So we want it in certain ratio so that the cost is $3.75. As you can see, if I do half and half, it's going to be a lot more expensive than $3.75. Does that make sense, guys? So that's what we're trying to do. Do you understand? And it makes sense that because one of them costs less than the other, right, we want to find a price right in the middle somewhere. Not in the middle, but somewhere in the middle between 2 and 9. Does that make sense? You understand what I'm trying to say? Is it possible to make this so that the cereal will be less than $2 per kilogram? Is that possible?
Yes.
Yes? No, it's not, because just putting the cereal by itself would be already $2 per kilogram. So you cannot make this price less than. But you can make it between 2 to 9, right? They want it so that it's $3.75. Do you understand what's going on? Okay? So what is our unknown here? Anais?
The amount of oatmeal, the amount of dry fruits?
Yes, that's exactly right. The unknowns are the amount of dry fruit and the amount of the oat cereal, right? Now, so we know combining them together, it should be 60. If I let X to be, the cereal, what do you think the other is? One person, come on. We should all know this. Okay, raise your hand. 2. Harrison, what do you think? If we let X to be the amount of the oat cereal, I said OC. What's got to be the other one? The dry fruit has to be then?
Yeah, $9.
Well, that's how much is per kilogram. We're talking about the amount of these things that we need. Elizabeth, can you help him out? Yeah, it's got to be 60 minus X, right, Harrison?
Yeah.
Because there are a total of 60 kilograms, right, of this new mixture we want. If I let X to be amount of the oat cereal, got to be total minus X. Remember, this is by logic. We did this for a whole semester, right? If the total amount is 60, if we let X to be one of them, the other has to be total minus X. Does that make sense? And as you can see, you see a chart there. Well, of course, we're going to have 3 things, right? The oat cereal, dry fruit, and then on the bottom, we're going to have the mixture of these 2. How much of the cereal are we going to put into this mixture? Yes? 15. Where did you get 15 from? It'll be X. Oh, you actually have the answer. I'm sorry. Oh yeah, it'll be X on the chart. Okay. And what about, Malia, dry fruit? How much of dry fruit are we going to? 60 minus X. If you're going to add X, the other has to be 60 minus X. And of course, the mixture at the end, we're going to have how much, class? 60. Yeah, makes sense. Now, so can you guys change this to price per kilogram? I wrote price by mistake. It should be price per kilogram, right? That's different. That's different, okay? Per kilogram, how much is it? So, how much is the cereal? $2. What about the dry fruit?
$9.
$9. Okay, now, For the mixture, do we do anything with 2 and 9 for the mixture? No, it's separate, right? We know it's got to be between $2 and $9, right? This mixture. How much do we want this mixture to cost? Whoa, raise your hand. How much do we want this cost here? Yes. $3.75.
Can we do like a 200, 900, 375?
Oh, you want to do it by cent? Yeah, but I probably wouldn't do it that way. But yes, you could do it that way if you like. Now, the total cost then, Andrew, what is the total cost just for the cereal that you're gonna have to pay?
X times 2.
Yeah, 2x. How much do we pay for the dry fruit? Michael, how about Andrew? Yeah, I'm sorry, Andrew just went. Chansu. 9 times 60 minus x. And what about the mixture? How much am I going to? How much would this mixture cost? Yes, Talib? Yeah, 60 times $3.75 is exactly right. Does that make sense, guys? So you see this chart is pretty similar now, but we have now third column here. Okay, that's the only difference. So then we need to come up with an equation, right? Okay, of course, the equation is where left side is equal to the right side. So does anybody see the equation? Anais?
2x plus 9 times 16 minus x equals 60 times 45.
Exactly. If you were to add how much it costs you, right, for the cereal plus how much it costs for you to add the dry fruit, it should equal to how much it's going to cost the whole thing, right, the mixture. Would you not agree? Do we know how to solve this simple equation? Yes, go ahead. Everybody, I'll give you some time. Go ahead and solve it, okay? By the way, does it make sense? Does this equation make sense, and does the chart make sense, guys? Yes? Okay, go ahead. Everybody try. All right. So, did you all distribute 9 to the 60 minus x? Okay. And then 60 times 3.75 is 225. Did you all get rid of, did you simplify the left side? You should have gotten 45. Okay, x equals to 45. And what does it mean? 2 people see 3? Yeah, Colby, what does it mean?
It means that you'll need 45 kilograms of cereal and 15 kilograms of fruit.
Very good. And where did you get 15 kilograms of the dry fruit?
Oh,
Malia, how did you get that? How did Colby get? Yeah, 60 minus 45. We knew that it has to be equal to 60, right? So does that make sense, guys? Right? At the end, the total cost, right, should be the same, right? From the dry fruit and then the cereal should cost 6 times 375, correct? And does it make sense? Does the answer make sense? So do we expect, no?
yes.
Do we not expect more of the cereal than the dry fruit? Because if you put a lot more dry fruit, yeah, it'll be a lot more expensive, right? So it makes sense. In order to bring down the cost, you have to add more cereal than the dry fruit. Any question? We good?
Yeah.
All right. You know what? I would like you to then, we're not going to go to the second one right now. I would like you to go at the end of your paper. It says, what is the concentration of water, that part? Okay, I would like you to see if you can answer all those 3. But give me a sec. I would like you to think about this for a second. But hold on. Okay, so when I say, listen, guys, let me be a little bit more specific here. When I say, what is the concentration of water? What I mean by this is, what is the concentration of acid in water? That's what I mean. Okay, so if it's not so clear, that's what I really mean. Second one, when I say, what is the concentration of pure acid? What I mean by that is, what is the concentration of acid of pure acid? Sometimes we use acid. Sometimes you will see in your homework they use juice. Sometimes they use salt. Okay, but it could be acid. So some sort of so when I say, what is the concentration of acid or pure acid? Can you write that down? I want you to think about it as a group. Hold on. And then the last one, it says, if I am making 10% grape juice mixture, I add grape juice to it. What is the percent of grape juice? That's the question. Yeah, question?
But for the pure acid, are you talking about like concentration of hydrogen?
No, just acid. No. Yeah, nothing like that. Okay. So I'll give you a couple seconds for you to think about it. So what do you think? What will go into those blanks? Okay, go ahead, think about it as a group. All right, I really like the kind of conversation that I'm hearing. It's great. Okay, so let me be a little bit more specific. First of all, when you drink water, when I say water, right?
Drinking water.
Right, drinking water or whatever. Is there any acid in there? Okay, so let me see. Okay, so when I say concentration, give it to me in terms of percentage. How many percent of acid is in the water? Raise your hand if you think you know. Shh, shh, shh. Okay, I hope this is Chanzu. 0%. You don't have any acid in the. I hope any water I'm drinking, that there isn't any kind of acid in there. Okay, what about the next one? So when I say concentration, I mean in terms of percentage. Okay, what is the concentration of acid, of pure acid? Because on your homework tonight, it will say, oh, I am adding acid to this solution. Or they could say, there could be more specific, pure acid. When they say acid, just think of it as pure, okay? Pure acid. Or when they say juice, they mean 100%. Okay, so what's the answer? Yeah. 100%, right? Okay. When I say acid or pure acid, everything is acid. So 100% of it is acid. Does that make sense? Like if I say I'm adding juice into this water, that means I'm adding 100% juice. Does that make sense? So even though I don't say pure juice or pure acid, know that this means 100%, unless I say otherwise. Does that make sense? How could I have said otherwise, like in terms of juice? Would all the juice be 100% juice? No, some will be 20%, some will be 50%, you know. Even the acids too. Not every acid will be pure acid, right? It could be 20% acid or 50% acid, right? And lastly, this last question. What do you guys think? If I have 10% juice, and look, it says I'm adding grape juice. When I say grape juice by itself, what does it mean? It means 100%. So who thinks they know what to write? Shrock?
It's 10%.
You think it's going to be 10%? So it'll be still 10%? So you have 10% grape juice. You're adding 100% grape juice into this. Will this juice still remain 10%? I don't think so. I think it's going to change. You think it's 110%? How do you have 110% grape juice? That's
It's overflowing out of the cup. It's from a
Okay, so
dark matter.
okay, so yeah. By the way, guys, listen. Even though because we're starting off with 10% grape juice, unless you put like really gigantic amount, it's not going to reach really close to 100%, right? Unless you put like a whole bunch. But because you have some water to begin with. But anyway, I don't think it's going to. Yeah, what do you think, Judy?
90%.
You think it's going to be 90%? What if you? Now, by the way, Judy, do they tell you how much of this they're putting in?
10%.
They could be putting in one drop, or they could be putting in like 200 liters of it. What do you think you're gonna say then? You have to say kind of carefully. 1, 2, 3, 4. Who haven't I called? I haven't called. Savannah, what do you think? Okay, you're right. There is not, but you could say something about the percentage of this grape.
Wait, no, wait.
Talene,
Did you write 10% plus X?
10% plus X. What do you think?
Wouldn't it be 100% because you're adding? So it's already 10% and then you're adding the rest around something.
Well, you don't know how much you're adding. I could be adding a drop,
X.
okay, or adding whole gallon worth of it. So,
It would still be 100%.
no. Okay, you have this solution, right? That is 10%. Only 10% is grape juice. Okay, and they don't tell you how much of this you're adding. You could be adding a drop of grape juice. Does that change too much? Or you could be adding 5 gallons worth of it. You don't know. So all you have to say is what? Yes, sir.
Wait, it says you're making 10% grape juice.
Don't worry about it. So let's say that you have. Okay, let's just say that you have 10% grape juice. You're adding a grape juice. What can you tell me about this percentage of this grape juice? Only thing you could say is, Emily?
More than 10%.
Yeah, that's all you could say. It'll be greater than 10%. Right? Okay, that's all. You can't really say much other than it'll be greater than 10%, would you not? Right? Would it be less than 10%? No, it's going to be more. You're going to have more grape juice in there. So.
So would it be greater than 10%, less than 1%?
Yeah, I guess you could say less than. Okay, sure, less than. You're right. It'll be greater than 10%, less than. It really depends on how much you add. Yeah.
I thought he was trying to make it like he hadn't made it yet, and then he added the.
All right. Okay. So I should have said. Let's say that he had 10% grape juice. So if. How about this? If I have. Is that better? If I have a 10% grape juice and I add grape. Is that better? Sorry guys. I should. So it should be written a little bit clearer. Yeah. If I have 10% grape juice and I add grape juice to it, it'll be. Would you all then agree that it'll be greater than 10%, less than 100%? Okay, great. Is that okay, guys? All right. Now knowing this, we can now go to the second example. Are we ready? Okay. So let's go to the second example. So before I get to the second example, I would like you to kind of imagine. Let's say that I have 10 milliliters of grape juice. That is 50% grape juice. So this is not. So I would like you to write this down underneath the part where we had all this. This is important. I forgot to add this thing. This is important because you need to be able to imagine this in your head. Okay, so if I had 10 milliliters of 50% grape juice, I'm sorry, 100. Now this is not pure grape juice, is it?
No.
So before you write this down, can you just close your eyes and imagine this in your head? Okay, imagine 10 milliliters of 50% grape juice. Everybody all close your eyes. Aaron, if you see me, then you're not closing your eyes. Okay, I want you to all close your eyes. Imagine this 50% grape juice. Now, what color? Okay, everybody. If you see me, that's not good. I want you to all close your eyes. Okay, what color is this grape juice? Raise your hand. Yes, Shirok?
Purple.
Purple. Is this really, really purple or kind of light? It's kind of light purple because you have.
Like water.
Right. Okay. Hold on. Good. Now, this is what I want you to do. Imagine this. Now, are you ready? With your imagination, can you separate the grape and the water?
Yes, you can.
Okay. Do it right now. Boom.
Because I'm God.
Okay.
Boom.
Okay. Hold on. Okay. So, okay. Listen. Okay. Now listen. When you separate it with your mind, the grape and the grape juice and then the water. What color is the water? Clear. It has no, okay. What color is the grape?
Extremely purple.
Really purple because it's 100% now, right? Okay. Now, how much? Listen. This is important. How much water do I have? Raise your hand. In your mind. Whoa. Raise your hand. How much water? Emily. How much? 50 milliliters. How much of grape juice do I have? Yes. 50 milliliters. Now you can open your eyes. Is this sort of the thing that you saw? This is what I imagine. Let's see how we're close. So, can you separate the water? Yeah. Now, right now, it's water and the grape juice are mixed. Yeah, mixed. If you separate them, don't I have 50 of each?
Yes.
And I have pure water, right? It'll be clear. And I have really 100% grape, 50%. Can you do this in your head? If you could do this in your head, it's going to be really helpful as we do the other examples. Does that make sense? This is what it means, right? When you have 50% grape juice, it means 50% is pure water, 50% of this solution is pure grape juice. When you add them together, it becomes 50% grape juice. Does that make sense? So let's do example 2 now. Okay, so example 2. Now this time, instead of grape juice, we have acid. Is that okay? So how many liters of water must be added to 20 liters of 24% acid solution to make a solution that is 8% acid? Okay. So think about this as a group. Does this even make sense? Okay, if it doesn't, go ahead and ask each other group. Okay, each other question as a group. Okay, so what's happening here? Some of you are still having trouble. You have 20 liters of the solution that happens to be 24% acid. Is this solution 100% acid? No. Is it 50% acid? No. It's 24%, means it's about 1/4 of it is acid, right? How much is water, really, if you think about it?
100%.
No?
0%.
Raise your hand. No?
6.
Okay, if it's, listen, I'm just talking about this, listen, give me a chance now. I'm talking about this 20-liter solution, right? This 20-liter solution, out of it, how many percent is just water? 76%. Because 24% is pure acid. Does that make sense? You understand what I'm talking about? Now, look what happens as I add more water to the solution. As we add more water, will this solution be more stronger? Is it more strong, or would it be weak? because you're adding more water, you're diluting it, it's be less acidic, right?
Yes.
Does that make sense? It's going to be less strong. Yes? So, yes, it is. Actually, this is what you actually do in chemistry. Now, when you have, listen, when you have added enough water, instead of this solution being 24% acid, now because it's weaker, it's only going to be 8%. Do you understand? Yes? Now, has the amount of acid changed? No. The amount of acid that was in there does not change, but how come the percent of acid changed? Who could answer that one? Derek?
Because you're diluting it with water.
That's right. There's more water now per, right? There's more water per this acid than before. Does that make sense? Because we're adding more water into this. You understand? So what is going to be our unknown? Raise your hand. Judy?
X equals the amount of water.
Amount of water we're adding. Would you not agree, guys?
Yeah.
Isn't this what we're trying to figure out? Now, this is how much water we need for what? For that this thing becomes 8%, right? So we're gonna have three things. Again, we're gonna have water that we're adding. We have 24% acid solution, and on the bottom we have the mixture. Now, how much water are we adding? So what do we write down for the amount? Raise your hand if you think you know what goes in there. Andrew? Do we know how much water we're putting in? So what do we call it's X. Now, how much of solution are we starting off with? Raise your hand. What's in other words, how much when it says solution amount, I'm writing down how much. Yes. 20. No, that's not the amount of the solution. That's the percent of acid. But how much solutions do we have, Shirok? For 24% acid solution, how much do we have?
20 liters.
20 liters. That's what it goes. Okay, now here comes the most important thing from this. What about the mixture? If you had 20 liters and you added X amount of water, how much of the mixture do you get at the end? By the way, what's happening to this solution? Is it increasing or decreasing, or is it staying the same? It's what? It's decreasing? You're adding water, so yes, what do you think, Kristen? It's exactly right. It will be 20 plus X. Do you guys see why it's all 20 plus X? Do you all see this? You're increasing this solution. You're adding water to this, aren't you? So now, instead of 20, it's going to be 20 plus X, because X is how much we need to add, right? So that this becomes 8%. Now, in water, as we said before, how much of the water is acid? 0%. How much of this 24% acid solution is acid? 24%. Do I write 24 or 0.24? What about the mixture? What do we want this mixture to be? 0.08. So this 0.08 has nothing to do with the percent acid we had before, right? It's got to be somewhere between 0 and 0.24, right? So we want it to be 0.08, which is 8%. Now, so do we know how to calculate how much acid we have in the water? Right? Well, in the water, there's 0% acid. So how much acid do we have from the water? 0. How much acid is coming from this acid solution? Our original solution. 0.24 times 20. What about from the mixture? Just like before, if you had 20 plus X amount of the mixture and you want this, when you want 8% of this, how much acid? Owen?
0.08 times 20%.
Yeah. Say it again?
0.08 times 20%.
That's right. By the way, I have a question. Do you think I'll be always adding water?
No.
On your homework, it's not always going to be water. What else could I add?
Grape juice.
No. Yeah, it's if it's acid. Now, no. When I'm talking about acid, I'm going to add another acid now, but maybe not pure acid. But I could add pure acid, or I could add 20% acid solution, 10% acid solution. This time it happened to.
Can you do mixed acid?
Yeah. So when I'm saying, well, we just use just one type. So yeah, it could be either 20%, 30%, or it could be pure acid. When I do, then the amount of acid is going to increase. Does that make sense? So it's going to be the percentage will go up. So on your homework, it'll be like that. Okay, does that make sense? But right now, I'm just doing it with water. With water, you don't have any acid. But some acid solution, if it's 20%, you're gonna have 20% of that solution you're adding is the acid, right? Anyway, what is then my equation? Now here's a picture. As you can see, this is why it's important to be able to separate. Our original solution, we had pure water and 24% acid. You see how I have the acid on the bottom, 24%? When you add more water, does the amount of acid change at all?
No.
No. So the acid from before and after remains the same. That's what an equation is, where left side is equal to the right side. So doesn't it make sense then when we add the acid from previous should equal to the acid from the mixture? So our equation should be what? Emily?
0 plus 20 times 0.24 equals 20 plus x times 0.08.
Excellent. And I like how you said 0 plus. Because would this be always 0, guys? No. On your homework, depends on what you're adding, right? It could be some acid solution, right? The amount of acid could increase. Does that make sense? Yes? And we want it equal to our amount of acid from the mixture. We get this. Okay, go ahead and solve. And if you have any question, ask your group for now, and then we'll go over it again. Go ahead. Now this is time to talk. Go ahead, guys. Discuss this, see if you could get this right. All right, here we go. So, did you all get, I hope you all got 40 as the answer. What does it mean? Raise your hand. How do I answer this as a sentence? What does x equal to 40 represent? Let's see. Somebody that I haven't picked. How about Nelly? What do you think? Amount of water what? You need to add is 40. What's the unit? That's correct. Okay, so that this becomes 8% solution. Does that make sense? So go from 24% to 8%, right? It's not, you can't like get rid of the acid. Does that make sense? But you could add more water to this. You get that? Okay. So only way to get to less strong solution is by adding water. You can't get rid of the acid because the acid will remain the same. Okay, it will still be in the solution. Any question? That's what I want you to keep in mind. Okay, you could control the amount of water you have. You can't control the amount of acid you have in there. Okay. All right. May I go to the third example? Okay. Good. Okay, so it says, how many kilograms of water must be evaporated from 20 kilograms of 5% salt solution? Now, this is kind of opposite of what we just did, right? Instead of adding water, what are we trying to do? Evaporating, we're trying to get rid of the water, okay? One way to get rid of the water is by evaporating this, right? Now, when you evaporate water, does the salt go away too? No, it remains in the water. Now, so it makes sense to go from 5% to 30%. Does that make sense? So if you obviously evaporate enough water, you could get 100% salt, right? Isn't that how we get salt from the sea and so forth, right? Now, what is that? What is the unknown then? Yes.
How many kilograms of water?
Yeah, how many kilograms of water we need to evaporate? Exactly right. So that's our x. So let's fill in this chart. Now, I didn't give you a chart, but you could kind of see the kind of chart you would get, right? It'll be, whoops. Okay. It'll be something like this. Right, it's always same, right? Original solution. Okay, amount of solution times percent salt equals to total salt. That's just as before. It's always kind of going to be same, right? Amount of solution you had. If you multiply that times how much, well, we had acid before, now it's percent of salt, it'll be total salt, okay? Instead of total acid, right? Yeah. Isn't that what this question is? Look at your, look. What? Amount of solution here, it's not salt. Amount of solution,
It's salt solution.
yeah, if you want to write salt solution, whichever. Okay. So you have amount of solution as before, right? This at the end you have the salt, right? Are you okay with this? It's pretty straightforward. Okay, now, I would like you to then all fill in the chart. Go ahead. Who thinks they know what the original amount of solution was? Anais? Why not? Okay. Now my question was, what goes into this box? Amount of original solution.
12.
That's right. We had 12, right? Before. Very good. What about evaporated? How much do we want to get rid of? Yes, Chansu? X. What's the new solution? This is the key. Let's see how many people got this right. Is it going to be 12 plus X?
No.
It should be what? Class 12? And that's why I actually put down negative X. Because when you're evaporating things, what's happening? You're getting rid of it, right? So you could put down X, I guess, but then you could remember to subtract. But I like to kind of start off with negative X there, right? Because you're getting rid of it now. You're not adding it. So when you add them together, you get 12 minus X. Of course, how much of this original solution, what percent of it is salt? 0.05. What about when you evaporate it? Are you getting rid of any of the salt there? It'll be 0. And what do we want the new solution to be? 0.3. Does that make sense? Because when you're evaporating, you're not getting rid of any salt or adding any salt. So percent of salt is 0. Okay. So of course, total amount of salt we have from the original is, of course, you multiply them together. The amount times percent, and of course, from evaporating, you're not adding or subtracting any salt. What about the new solution? How much of it is the salt now?
Student.
You know that amount of salt is to simply multiply 30% to 12 minus X. Now then, the important question is, what is going to be our equation? One person knows 2, 3, 4, 5. Kyle, can you give me the equation?
12 times 0.05
Yep.
equals 0.3 parentheses 12 minus X.
You're right. Kyle, how did you get that equation? By the way, I wrote down if X is the amount evaporated, 12 minus X is how much you have at the end, right? Anyway, go ahead. How did you come up?
That's what it is.
Right. Well, who could explain why we get that equation? Why do we get this equation? Who could explain to the class?
Oh,
Okay, Colby?
never mind. I lost my train of thought.
Hey, imagine what's happening here. What does 12 times 0.05 represent? And what does 0.3 times 12 minus X represent? No one knows why? Emily, try it.
Because the 12 times 0.05 is the original solution, and then you're subtracting how much salt was evaporated. Wait, no, sorry. Yeah, keep going. And then that equals the new solution.
Do they represent the... What about the old and the new solution?
Because the new solution includes the water.
Yeah,
Oh!
what does this number represent? Yes.
It's the total amount of salt.
Yeah, that's the amount of salt. Guys, does the amount of salt change at all? No. The percentage changes because we're getting rid of the water. But from the original, does the salt evaporate? No, it still remains in the solution. Right? So if you're just looking at the salt, right? Imagine if you were to, right, evaporate water. Remember how we were able to separate the salt and the water in our head? Right? When you just get rid of the water only, does the amount of salt change? Hello? Are we listening? The amount of salt doesn't change. That's why they're equal to each other. The percent of the solution changes, but not the amount of salt. Does that make sense? So go ahead and solve, see what you get. I think some of you already done. Okay, go ahead, solve it. So, did you all get 10?
Yes.
Good. So what's it mean? We need to write this as a sentence. Wait. Marilyn, what's it mean? Shh. Huh? That's right. 10 kilogram of the water must be evaporated so that it becomes... How many percent do we want?
30%.
Yeah, so that is 30% salt. Any question? Yes? Are we good?
We're good.
All right.